There are moments when the sky does not merely whisper its secrets. It pours them upon humanity with the force of a revelation, shaking every certainty we thought we had consolidated within the pages of astronomy textbooks. In the cold, indifferent darkness that separates the worlds, there exist planets so elusive they escape even the sharpest eyes, mysterious orbits poised between birth and oblivion. Yet it is precisely in these abysses, where the light of the stars dissolves into cosmic silence, that the James Webb Space Telescope has traced a new path, bringing unexpected protagonists into the spotlight. Worlds like TWA 7b and the astonishing family of super-Venuses. To grasp the significance of what is happening, one must shed every preconception about what it means to see a planet. For centuries, worlds beyond the solar system were nothing but a bold conjecture, hypothesized by philosophers, dreamers, and a select few scientists who defied academic caution. Only in recent decades, thanks to the relentless advance of technology, have we had confirmation of their existence. But no one could have anticipated the barrage of surprises that James Webb, with its infrared gaze, would unleash upon Earth's laboratories. The event that shook the scientific community was the direct sighting of TWA 7b, a gas giant orbiting a young star just over 34 light-years from Earth. Until now, its presence had only been suspected, hidden by the blinding glare of its parent star. Only the almost surgical precision of Webb's instruments, aided by a sophisticated coronagraph, managed to isolate the planet from the sea of starlight. And what appeared was incredible: a massive body, with a mass more than 100 times that of Earth, wrapped in a warm atmosphere, likely swept by powerful winds and adorned with exotic clouds that reflect light in the near-infrared. This is not just a technical achievement. TWA 7b is the first exoplanet detected thanks to an integrated coronagraph on Webb, a technology capable of dimming a star's light enough to make visible what would otherwise remain forever hidden. The direct image of this world has inaugurated a new era. If before we could only guess at the presence of exotic planets through the shadows they cast on their stars, we can now finally scrutinize them in detail, study their atmospheres, estimate their temperatures, in this case, around 48 degrees Celsius, and even hypothesize the chemical composition of the clouds above them. The echo of TWA 7b's discovery had not yet faded when other unusual planets began to claim their place in the chronicles of cosmic exploration. Thus, the so-called super-Venuses made their entrance, worlds that do not fit into any of the classic categories with which science has tried to catalog the universe. They are not simply super-Earths, too large and hot to resemble our planet. Nor are they sub-Neptunes, as their atmospheres are not dominated by hydrogen and helium. Instead, super-Venuses seem to have chosen a wild middle path. They are scorching worlds, with dense carbon dioxide atmospheres, shrouded in acidic clouds and climatic processes at the very edge of the imaginable. Webb's instruments intercepted the chemical signature of these worlds by analyzing the spectrum of light filtered during planetary transits. When one of these planets passes in front of its star, a fraction of the light passes through its atmosphere, leaving its mark. This is how it was discovered that some of these super-Venuses have atmospheres surprisingly similar to that of Venus, but with extreme variations. Atmospheric pressures tens of times greater than those on Earth, surface temperatures capable of melting lead, and a density of carbon dioxide sufficient to generate uncontrollable greenhouse effects. But that's not all. What makes these planets even more enigmatic is their very process of formation. According to current models, worlds of such size should rapidly become gas giants, accumulating vast amounts of hydrogen. Yet these super-Venuses seem to have followed a different evolutionary trajectory. They have maintained a compact size, never ballooning into the imposing bulk of a Neptune. Some astronomers speculate they are the result of extreme planetary migrations, with planets forming much farther from their star and then, over millions of years, plunging into inner orbits, losing the lighter gaseous layers and retaining heavier, more stable atmospheres. The fascination of these worlds goes beyond mere physical strangeness. They are true cosmic laboratories where we can study the limits of atmospheric physics, planetary geology, and perhaps even the boundaries of habitability. For if Earth represents a rare balance between atmosphere, water, and temperature, supervenuses show us a radical alternative, where life, as we imagine it, would be doomed to an impossible existence. But the history of the cosmos is full of surprises. Environments once thought inhospitable, such as the depths of Earth's oceans or the fumaroles of Jupiter's icy moons, have proven to be hotspots of biodiversity. Who knows if even in these planetary furnaces, perhaps underground or in the shadow of gigantic acidic clouds, some form of life adapted to conditions that defy our understanding might be hiding. The quest for TWA-7b and the supervenuses is not only a scientific endeavor. It is a philosophical challenge, a call to abandon the presumption that the universe must replicate the rules to which we are accustomed. Webb is teaching us that reality often surpasses even the boldest hypotheses, and that the variety of worlds out there is perhaps broader than even the most visionary science fiction writers had imagined. And while its antennas continue to search among dust and light, new questions arise, ready to push science toward yet unexplored horizons. Thus, as the James Webb Space Telescope plumbs the depths of space, the very perspective of planetary exploration is changing. The atmospheres of supervenuses appear, to spectroscopes, like ancient palimpsests written by unknown hands. Layers of opaque gases overlap in whirls of sulfuric acid, electrical storms rip through the clouds with flashes of energy, metallic rains fall to the ground in infernal cycles. Yet the true revolution lies in the way this data is deciphered. For the first time, science can observe the formation of clouds, the accumulation of greenhouse gases, the variations in pressure and temperature not as mere numbers, but as events in progress, recorded almost live on worlds millions of billions of kilometers away. On the surfaces of these planets lies the story of ancient catastrophes, gigantic impacts that have disrupted orbital layouts, tumultuous migrations through primordial dust disks, atmospheric loss processes that have forever reshaped the chemical composition of their atmospheres. Some supervenuses may have started as water worlds, with primordial oceans that, following waves of radiation and extreme climate change, evaporated, leaving behind an environment dominated by carbon dioxide. These hypotheses are not mere speculation. Traces of dissociated water and rare isotopes, detected thanks to Webb's precision, suggest that many of these planetary furnaces may have had a surprisingly similar past to that of our own Earth. TWA-7b, for its part, offers an even more enigmatic scenario. Its size, its disproportionate mass compared to its relatively mild temperature, and the young age of its host star suggest an accelerated formation process and perhaps chaotic accretion events that allowed such a planet to survive so close to an unstable star. Preliminary data suggest a dynamic atmosphere, crossed by swift storms and chemical transitions that change within a few Earth years. Webb, with its golden eyes, can detect the variation in the planetary spectrum in real time, offering the first true extraterrestrial weather report in human history. But perhaps the most astonishing aspect of this new phase of astronomy is the way in which the very concept of habitability is breaking apart. Scientists, accustomed to searching for Earth-like copies among the stars, now find themselves facing a universe that seems to favor diversity, excess, and unpredictability. Supervenuses, with their carbon dioxide hells and impossible pressures, were long ignored as dead worlds. Today, however, they represent a new frontier in understanding the limit conditions for the survival of organic matter, for the persistence of liquid water, and even for the establishment of life forms based on alternative chemistries. Imagining biology on such a world requires a leap into the unknown. There is speculation about the possibility of sulfur-based organisms, capable of withstanding scorching temperatures and crushing pressures, or perhaps life forms radically different from those on Earth, accustomed to cycles marked by acid rains and phases of violent evaporation. In the laboratory, analogous conditions are recreated in test tubes, testing the resistance of complex molecules to levels of radiation and heat that would destroy any cell on Earth. Every negative result is not a disappointment, but a new question. What are the true limits of life? Where do the boundaries of the possible hide? At the same time, the technical challenge becomes ever more daring. Detecting the faintest variations in the spectrum of starlight, isolating the voice of a planet from the cosmic noise, is a feat that would have been unthinkable just a few years ago. Artificial intelligence algorithms analyze billions of data points per second, identifying patterns the human eye would never perceive. Simulations, based on data collected by Webb, make it possible to virtually travel to the surface of these planets, immersing oneself in oceans of toxic clouds, observing alien landscapes through infrared filters, listening to the whisper of planetary winds as if we were there, suspended between a lightning storm and the distant glow of a dying star. As images and data pile up in research centers, the fundamental question remains, perhaps even more urgent. What do the discoveries of worlds like TWA 7b and the super Venuses truly tell us about Earth's fate and the very nature of life? Are they merely statistical anomalies, improbable extremes of a random distribution, or do they represent an inevitable stage in the evolution of any planet that, for a moment, found itself in the ideal conditions to host oceans, blue skies, and perhaps conscious thought? In the silence of laboratories and the infinity of space, the answer remains hidden, but the search goes on, driven by the certainty that every new discovery, every shadow detected among the stars, adds a piece to the incredible mosaic of cosmic reality. Thus James Webb, as it continues its investigation in the darkness, keeps redefining the boundary between known and unknown, between dream and science, between the nostalgia for a universe like our own and the dizzying realization that, out there, planetary diversity may not be the exception, but the rule. And we, once again, are called to reinvent the way we observe, imagine, and perhaps, one day, explore these incredible worlds, pushing ourselves beyond the limits of our certainties. If you've made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment, and subscribe to the channel. It's the best way to support what we do. Your presence truly makes a difference. Until the next exploration.